Hello steamers. So, I take it you took a guess and you've come here. Now, if you answered B, you were right. Now, for those of you who didn't answer B, you might want to know why B was the correct answer. So let me break it down to you. So, start off looking at this bottle. This bottle is made of glass, and the glass is in a solid state. That means the particles, the molecules that make it up, aren't moving around, they're pretty fixed. But when something's in a liquid state, the molecules are more free to move around. But if you was to heat up that liquid to turn the water into a steam, it would become a gas. It would evaporate into the gas. And when it evaporates and becomes a gas, the particles and the molecules now have more energy. They move around faster and they take up more space. Now that moving around faster and the more space it tries to take up exerts more pressure. Now what we said before is there's a balance between the pressure inside and outside the bottle because it was open, but that was just in normal circumstances. But when we changed the liquid into a gas, now the pressure has increased inside the bottle as the steam takes up more space. Now things tend to move from a region of high pressure to a region of lower pressure. So what happened next? Well, next we took the hot bottle and we stuck it in the water. So when we stuck the bottle in the water, the hot steam inside comes in contact with the cool water in the bowl. As the water starts to cool down the steam changes from a gas and it condenses back into a liquid. Now as a gas, it took up 1,600 times more space. So now it wanted to squeeze itself back as much as possible. Now because of that, it exerts less pressure outside. Now that decreased pressure has now reduced to below the pressure outside. So remember earlier I said things will move from a region of high pressure to a region of low pressure. Well, because inside the bottle is now at a lower pressure, which we actually call a partial vacuum, it causes the air outside to get pushed in and sucked into the bottle. Now because the water's in the way, what ends up happening is the water rushes into the bottle before the air manages to. And the water keeps rushing in until the pressure inside the bottle and the pressure outside it have equalized again. They have achieved equilibrium. Demos like this are useful for understanding some of the work that aircraft engineers have to do in designing planes. They have to keep the inside of the cabin pressurized, whereas the outside is a reduced pressure. If anything was to go wrong in the plane, well, everything would try to move from a region of high pressure to a region of low pressure, just like the water did. To find out more about some of these experiments that we're doing here on Head Steam, why not subscribe? You might even see about my one about the science of cakes. Speaking of cake.